Welcome to Chemistry YouTube channel. Karnataka CSET 2014 Chemical Science Paper 2 50 questions with explanatory answers Part 4. IUPAC name of the following compound is. Here you see this compound, it is 1 2 in. Here the double bond, you give first preference to double bond. So it is position 3 and this is 4. The OH group is present at position 4. You have to name the carbon where the double bond starts. So it is a 2 in 4 all. It's a 2 in 4 all. 2 in 4 all. In option D, it was given it is a R compound. No, this compound was S. This compound was yes. Hence, option A was ruled out. Option C was ruled out. It is a S compound. So, option D was ruled out. Hence, answer is B. E 4S hept 2 in 4 all. Okay. Next question. Which is a meso compound? Which among the following is a meso compound? 2R 3R 2,3 dibromobutane, 2R 3S 2,3 dibromopentane, 2R 4S 2,4 dibromopentane, 2R 4R 2,4 dibromopentane. Here the answer is C. Listen, 2R 4S dibromopentane, you have two equal parts. It has a planar symmetry. You take compound C. In compound C, it has a planar symmetry. The compound structure was given like this. Hence, it is a planar and is a meso compound. Whereas you see, for option B was given like this, and this was not a planar. And this was not a planar structure, and you will not end up with a meso compound. Hence, option B was ruled out. You take option D. Option D is a 2,4 dibromopentane, and this was also this was not give meso compound, but it will give DL compound. It gives a DL mixture. Hence, option D was also ruled out. Option A was ruled out because it is a butane. Hence, option C is correct. Next question, 33. Which of the following statement is correct? For the two compound 1 and compound 2 was given. Which is aromatic? Both are aromatic. Compound 1 is anti-aromatic and compound 2 is aromatic. Compound A is aromatic, compound 2 is anti-aromatic. Both are anti-aromatic. There are given 4 options. First you take aromaticity. First, in aromaticity is a 4n plus 2 rule. That is, a compound containing 2 electrons, 6 electron, 10 electron, 14 electron, etc. are aromatic. We know that. And for anti-aromatic, it is a 4 electron system which contains 4 electron, 8 electron, 12 electron, 16 electrons are anti-aromatic. This rule we have to know this. In case of first compound, you take first compound, it is a cyclopentadienyl anion which contains 6 electron. This is 2, 4, 5, 6 electron. It contains 6 electron in the pi system, hence it is a aromatic compound. You take compound 2. So compound 2 is a cycloheptatrienyl anion which contains 8 electron. You see there are 3 pi bond, 3 into 2, 6 electron, and one anion, so 2 electron, hence it has 8 electrons. It is a anti-aromatic. It is a 4n system and highly unstable. Okay, hence answer here is C. Compound 1 is aromatic, cyclopentadienyl anion, and compound 2 is anti-aromatic. Okay. Next question, 34. Which of the following carbenes are electrophilic in character? CH2, CBr2, CCl2, CHO, CH3. Listen, carbon in carbene, carbon atom in carbene, that is dibromocarbene, dichlorocarbene, there are 6 electrons. You see, in dibromocarbene and dichlorocarbene, there are 6 electrons. That is, listen here. Here it's a carbon. Here one Br and here one Br, and here there are 2 electrons. So totally 1, 2, 3, 4, 5, 6 electrons. But carbon should to attain octet, carbon should have 8 electrons. Okay, it does react with the electron rich species with olefins to get sextet to complete its octet. So 1, 2 and 3 are electrophile. Okay, there are 2 electron deficient for compound 1, 2 and 3, which contains 6 electrons, these 3. Whereas compound 4 is a nucleophile. Hence option D is correct. Hence option D is correct. Next question. Hydrolysis of an ester is an example of. Hydrolysis of an ester, you here see an ester on hydrolysis gives an acid and alcohol. So it's a substitution reaction. It is not an addition reaction. It's not an addition reaction. There was no atom was eliminated, so it is not an elimination reaction, and it was not an oxidation reaction. It is a substitution reaction. Option D is correct. Next question. The conversion of COCH2 to CH2CH2 rising mercury bar zinc and HCl is known as Clemmensen reduction. We all know that CO becomes, that is CO bond becomes CH2 bond. This one method is a Clemmensen reduction, we all know that. The alternative for the same conversion is known as, here you see Birch reduction was ruled out because we cannot convert a C double bond O to CH2. And Wolff-Kishner reduction was the correct answer, where here you use C double bond O with reagent diphenylamine hydrazine. In presence of a base, you will get CH2. The C double bond O bond becomes CH2 bond. MPV reduction was also ruled out. Rosenman reduction was also ruled out. Here, in Wolff-Kishner reduction, which was similar to Clemmensen reduction. Wolff-Kishner reduction was similar to Clemmensen reduction, where the reagent only changes. In Clemmensen reduction, it was mercury bar zinc HCl. Whereas in Wolff-Kishner reduction, it was hydrazine in presence of base. But the conversion was same. Next question, 37. The major product formed in this reaction is, given the reactant was given LiNH3BuOH beta hydroxide. What was the product? Here the reaction is a Birch reduction reaction. In Birch reduction, 1,4-cyclohexadiene. Here what happens, you see, you take benzene. If you add CH3, CH2OH, then what happens is CH bond forms CC bond. Another CH bond becomes OH bond. Another CC pi bond, that is C double bond C, becomes OH and C single and another C double bond C. So On applying the same principle and same rule, you will end up with answer C. You will end up with answer C. Next question. Synthetic equivalent of synthon, COOR, C double bond O, OR dash is. Here in retrosynthetic analysis, a synthon is a hypothetical unit within a target molecule that represents a potential starting reagent in the retroactive synthesis of the target molecule. You see here, option A was correct. Here you end up with the synthon COOR dash, whereas in option B you will not end up with if you break molecule B, you will not end up with COOR dash. And here in option C was also ruled out, you will not end up with this molecule COOR. This option D was also ruled out, hence answer A was the correct answer. Next question. Chiral auxiliary is mesotartaric acid, glycine 4,1,4-dibromobutane, binaphthalene. Here binaphthalene was the correct answer. Binaphthalene 2,2-bis diphenyl phosphino 1,1 binaphthyl is an organophosphorus compound. This is a chiral diphosphine ligand, is widely used in asymmetric synthesis. It consists of a pair of 2 diphenyl phosphonyl naphthyl group linked with 1,1 position. Here you see this. This C2 axis symmetry lacks a stereogenic atom but has axial chirality due to restricted rotation, that is atrope isomerism. So chiral auxiliary is a stereogenic which was present in binaphthalene compound. So answer D is correct. This chiral auxiliary was not present in mesotartaric acid and not in glycine and not in 1,4-dibromobutane. Answer is D. Next question. Reaction of hexa 1,3,5 triene to give cyclohexa 1,3-diene is an example of. You see, the formation of cyclo 1,3-diene, hexa 1,3-diene by heating hexa 1,3,5 triene is an example of. It's a ring closure electrocyclic reaction. You see here, this bond shift here, this bond shift here, and this bond shift here. So you will get a new sigma bond was formed, and this was a ring closure electrocyclic reaction. It was not an cycloaddition reaction. You are not adding one compound with another compound. So cycloaddition was ruled out, and it was not a sigmatropic reaction. It was not a 2,5,3,3 sigmatropic reaction like this, and there was it was not also a cheleotropic reaction because no electrocyclic reaction where ring closure occurs by shifting of bond. We will meet on the next video. Thank you.